Probability in Stats Lesson 4 is compound events. A simple event is an event that describes a single outcome. So for example, if I'm looking at even and prime numbers, the probability of picking an even number. A compounded event is an event made up of two or more simple events. So somewhat we were talking last time. For example, an even number or a prime number, or an even number and a prime number. Mutually exclusive events are events that cannot both occur at the same time, so their intersection would be 0. So for example, you can't flip both a head and a tail at the same time, so those would be mutually exclusive. If you're finding the probability of an or, so A or B, of mutually exclusive events, it's just the probability of event A happening plus the probability of event B happening. Inclusive events are events that have one or more outcomes in common. So for example, a even number and a prime number, 2 is both even and prime. So those would be inclusive events. And the probability of A or B for inclusive events is the probability of A plus the probability of B minus the probability of A and B. Because if you take the probability of A, you've included, for example, 2. If you take the probability of B, you've included 2 again, so you double counted that intersection, so then you need to subtract that back off. A group of students is donating blood during a blood drive. A student has a 9 out of 20 probability of having type O blood and a 2 out of 20 probability of having type A blood. Explain why the events type O and type A blood are mutually exclusive. So again, mutually exclusive means they can't have any overlap. So for this, you can't physically be both type O and type A at the same time. So that's why they're mutually exclusive. So if we want to find the probability that a randomly selected student will be either type A or type O, then because these are mutually exclusive, if I want to find the probability of being A or O, I can find the probability of being A plus the probability of being O. So the probability of being type A, they tell us, is 2 out of 5, and the probability of being type O is 9 out of 20. So if I add those together, I get 17 out of 20. Each student casts 1 vote for senior class president. Of the students, 25% voted for Hunt, 20% voted for Klein, and 55% voted for Vila. A student from the senior class is selected at random. So explain why this scenario is mutually exclusive, and then what's the probability that a student voted for Klein or Vila. So go ahead and pause the video and try these. So this situation is mutually exclusive because you can't vote for more than one person, so there's no overlap, there's nothing in the intersection. So the probability of picking someone who voted for Klein or Vila is going to be equivalent to the probability of voting for Klein plus the probability of voting for Vila, so I added those up and I got 0.75. A fair 6-sided die is rolled. Find the probability of rolling a 4 or an even number. So now this situation is no longer mutually exclusive because there's overlap in 4 and an even number because 4 is an even number. So when I find the probability of this or, I have to take that into account. So the way I'm going to calculate it is I'm going to find the probability of rolling a 4, and I'm going to add the probability of rolling an even number, just like we've been doing. But we have double counted that 4 twice, so we need to subtract off that intersection. So the probability of rolling a 4 or an even number is 1/6 for the probability of rolling a 4, plus 3/6 for the probability of rolling an even number, minus double counting that 4 again, minus the 1/6. So I end up with 3/6 or 1/2. So if I want to find the probability of rolling an odd number or a number greater than 2. So if I'm going to calculate that, I'm going to find the probability of it being odd plus the probability of it being greater than 2 minus the probability of it being odd and greater than 2. So there's 3 out of 6 for odd, there's 4 out of 6 for greater than 2, and 2 of those are also odd, so I'm going to subtract those back off, and so I end up with 5/6. A card is drawn from a standard 52 card deck. Find the following probabilities. So go ahead and pause the video and try these ones. So to find the probability of a king and a heart, I did the probability of a king plus the probability of the heart minus the overlap because there are kings that are hearts. So there are 4 kings out of 52 cards in the deck, and there are 13 hearts out of 52 cards in the deck, but one of them is both a king and a heart, so I'm going to subtract that back off. So you end up with 16 over 52, or 0.307, or 4 over 13. The probability of pulling a red or a face card is going to be the probability of red plus the probability of face minus the overlap for the red face cards. So there's 26 out of 52 red cards in the deck, 12 out of 52 face cards in the deck, and 6 of those are red. So I'm going to subtract that back off, so you end up with 32 over 52. Of 1,560 students surveyed, 840 were seniors and 630 read the news daily. The rest of the students were juniors. Only 215 of the newsreaders were juniors. So we want to draw a Venn diagram to help us represent this situation. So my two groups are going to be my seniors and those who read the news daily. Now for a Venn diagram, the part that's inside the senior circle but not in the overlap would be seniors who don't read the news. The overlap would be seniors who do read the news, and then in the news circle outside of this overlap would be, in this case, juniors or non-seniors who read the news. And then outside everything would be those who are neither seniors nor read the news. So I know 630 total people read the news, but 215 of them are juniors. So I'm going to put that over here because that's how many people read the news that were not also seniors. So then if I figure out the overlap, it's going to be the 613 minus the 215. So there are 415 seniors who read the news. So then if I want to figure out how many seniors don't read the news, I'm going to subtract that 415 from the 840, and you get 425 seniors that do not read the news. So then for the juniors who don't read the news, I'm going to take the total number surveyed and I'm going to subtract each of those three numbers to figure out how many people are left over, and we end up with 505. So there were 505 juniors that did not read the news. So they were neither seniors nor read the news. So now we have this Venn diagram set up. Go ahead and use it to help you find the probability that a randomly selected student is a senior or somebody who reads the news. So to find the probability that someone is a senior or reads the news, I'm going to find the probability that they're a senior plus the probability that they read the news minus that overlap. So there were 840 out of 1,560 seniors plus 630 people who read the news out of the 1,560 minus this overlap of 415 out of the 1,560. So I get 1,055 out of 1,560. Each of 6 students randomly selects a butterfly from a list of 8 types. What is the probability that at least 2 students choose the same butterfly? Hint, at least 2 would be the complement of all choose different. So we want to figure out how to calculate the probability that 6 students basically all choose different butterflies and then take the complement of that to find that at least 2 students choose the same. So the first 2 things I figured out were the total number of possible outcomes, which is a permutation with repetition. So there are 8 things and you are choosing 6 of them in any repetition or combination. So it's 8 to the 6th power, which is 262,144 different ways those 8 butterflies can be picked. Then if I want to specifically choose 6 different ones, I'm picking 6 out of the 8 specifically, and order matters because I'm assigning them to students and different students can get different butterflies. So I'm going to do 8p6, it's a permutation without repetition, and I get 20,160. So then the probability that they're all picked different butterflies would be the 20,160 over the 262,140. So then the probability that at least 2 choose the same would be 1 minus that probability, and you end up with 241,984 over 262,144. So this is combining complements and permutations all into one probability setup.